This is what happens in week 9. So buckle up. So last time, when we were looking at sine waves, we threw in these 4 constants, A, B, C, and D, and they did some things. So we sorted out what they did, and we just want to be more specific about how they're going to show up in the graph. What are they going to do to modify the graph? So yesterday modulo this class, we learned this plus D. This moved the graph up and down. So this was a vertical. And since it's moving up and down and not changing the shape, we're going to call it a vertical shift. Shift maintains the shape, just moves up and down. We also saw shifting with the C. Changing the value of C would shift the graph left and right. So we're going to call that a horizontal shift. That C is going to create a horizontal shift. When we multiply by B, B produces a horizontal stretch or a squish. I'm just going to say stretch. It's going to be a horizontal stretch, and then compression will just be -1 times stretch. So horizontal stretch or compression. So changing the value of B changed some horizontal stretch or compression, but it didn't squeeze, even though we squeezed in, it didn't like squish out the top. So it didn't like, it was just independently squishing in like an accordion. Changing the value of A stretched things vertically. Then I asked if there were things that were similar, some things that were similar and some things that were different. So there are actually 2 categories that we were looking at. I see horizontal and vertical, and I see shifting and stretching. So there's like those 2 categories in each one. So that means 4 possibilities. There's horizontal and vertical, stretching and compression. Sorry, stretching and shifting. So we got vertical, vertical, horizontal, horizontal. Stretch, stretch, shift, shift. Shifting, stretching, horizontal, and vertical. We also found some default values. The default values for A our default values for A and B were 1. And the default values for C and D were 0. The default values for A and B are 1. The default values for C and D are 0. If we look at the expression y equals A cosine of B times theta minus C plus D, what operation is associated with both A and B? What operation is associated? Actually, let's go with C and D. What operation is associated with C and D? What operations do we see? How are C and D included in this function? What operation is going on there? Addition, we see D is added and then C is being subtracted. It's addition and subtraction. So it makes sense that the default value there is 0 because adding or subtracting 0 does nothing. No effect. Notice that D is a shift and C is also a shift, included by addition or subtraction. Now for A and B, what operation includes A and B? How do we include A and B? What operation do we use to include A? I can't write that sentence. What operation are we thinking of? Multiplication. Does it make sense that the default value for A and B is therefore 1? Why does it make sense that the default is 1 for A and B that are included by multiplication? Multiplying by 0 would be nothing. What does multiply by 1 do? Doesn't change anything. Multiply by 1 changes nothing. Adding 0 changes nothing. So it makes sense that the ones that are included with addition have a default of 0. The ones that are included with multiplication have a default of 1. Any questions? Comments? I want to label some parts on a graph. I've built a frame here. I'll give you a copy of the frame. Oh, it didn't come out in color. I don't have a color copy for you. Freaking excessive amount of paper. So what we want to do is we want to name some parts. We want to name some parts. So here are some names of parts that we want to label. So vertically, I have, you see this red line in the middle, and then at the top and the bottom, I have a blue line. So in the middle, we're going to call this the middle. That's going to be the middle. We're going to refer to the top of the graph as the top. We're coming up with clever names today. And we're going to refer to the bottom of the graph as Francis. I'm just kidding. Bottom of the graph is the bottom of the graph. So we have a top, a middle, a bottom. Now I've got this orange start line and I've got a green finish line. The distance between the start line and the finish line is going to be 1 period. The period is the length of 1 cycle. So a cosine graph goes top, middle, bottom, middle, top. That's 1 cycle. However long that takes, that's 1 period. One period is broken up into 4 quarters for the 4 quadrants. Each of them is 1/4 of a period long. So here's a quarter period. This is a half period. This will be at 3/4 of a period. and then this is 1 full period. The period is broken down into 4 quarters. So if the period is 100, each of these quarter periods will be 25. This represents us going through the 4 quadrants of the unit circle. Now, if we draw a cosine will say starts at the top. Even though the graph goes on forever in both directions, we think of cosine as start at the top. So the cosine will start at the top, and then go to the middle, then the bottom, then the middle, and then the top. The way I'm going to phrase this is I'm going to say cosine starts at the top. Cosine starts at the top. If we want to draw a better graph, we need to know where our halfway points are. So our halfways are 30 degrees before and after we cross through the middle. So halfway, 30 degree, or sorry, pi over 6 radians before and after. Then we connect through the middle with just line. Connect through the middle with a line. Flatten the graph on the bottom and the top. If you want a little extra detail, go for your pi root 3 over 2s. There's our regular cosine. Regular cosine starts at the top. Another value that we want to label is the distance from the middle to the top and the middle to the bottom. It's the same amount from the middle to the top and the middle to the bottom. That's why we can call the middle the middle. If the middle isn't in the middle, we couldn't call it the middle, but we call it the middle, so it's in the middle. Distance to the top and the bottom is the same. We refer to the distance from the middle to the top as the amplitude. The distance from the middle to the top is the amplitude. The amplitude is a distance, so it's always going to be positive. And it will be the same as the distance from the middle to the bottom. So locations, we've got a top, a middle, and a bottom. Distances from the middle to the top is an amplitude. From the middle to the bottom is an amplitude. from one point to the corresponding point is one cycle. From the top to the top is a cycle. Or sorry, the length of that is one, and the length of a cycle is a period. When you get to the point where you're going to be repeating what you just did, that is one cycle. The length of that cycle is 1, 2. We're going to think of cosine starts at the top. That's the way we're going to think about it. And we're going to think of the order of the points as the top, we have a top, then the middle going down, then the bottom, then the middle going up, then we're at the top again. And then we just repeat this. We have two ways that we pass through the middle. There's a middle going down, and there's a middle going up. Depends on where we're coming from and where we're headed. Coming from the top, middle going down. Headed towards the bottom, middle going down. Coming from the bottom, middle going up. Head towards top, middle going up. Cosine starts at the top. Sine is a little different. Sine starts at the middle. Specifically, the positive version of the middle going up. So if we're at the middle and we're going up, then the next point is going to be at the top. Then after the top is the middle going down. After the middle going down is the bottom. Then we're back at the middle going up. If we want to make a nice graph, we find our halfway points, which are 1/3 of the way as we pass through the middle. We connect our middles with lines, even though they're not linear. They're close to linear. We're going to be flat at the top and the bottom. And if you want a little more detail, we can approximate our root 3/2. Then we can draw these awesome sine waves. All these points, these named points, top, middle going down, bottom, middle going up, all those named points have a quarter of a period in between them. So notice there, here's a quarter period, or here's 1 period. Here's 3/4 period. Here's a half period. Here's a quarter period. They represent, those quarter periods represent each of the 4 quadrants. That's why there's 4 of them. So we're going to think of cosine as starting at the top, and we're going to think of sine as starting at the middle going up, the positive version of each of those 4 named points. The top is a positive. We're thinking of the top as a positive point, the middle going up as a positive point. So the bottom is a negative top, and the middle going down is a negative middle going up. So we're thinking of the top and the middle going up as positive. We're thinking of the bottom and the middle going down as negative. Questions? It's just naming of parts. Is what I mean by one cycle. The period is the length of one cycle. The amplitude is the distance from the middle to the top. So something about how tall the graph is. How's that okay? The amplitude that we're mentioning here is the same amplitude that you know about in your AM radio. Your AM radio is working on amplitude modulation. That's what the AM stands for. So they're sending you a signal that's kind of going like this. We're modulating the amplitude. This is a super grossly oversimplified version of how it works. Don't at me in the comments, radio experts. I turn comments off so you can't even. So, and then FM is for frequency modulation. And so that means we're modulating the frequency. Frequency is just how often something happens. So it's the reciprocal of the period. So when the frequency goes up, that means the period is shrinking. So FM is going like this. AM is going like this. XM is just a bunch of ones and zeros. And when it came out, X was the cool letter to put in front of everything. Well, what are we going to call this digital radio? Then they're like, oh, how about XM? And then I go, yeah. And then they listened to some new metal and drank some Mountain Dew. But they didn't just like drink the Mountain Dew like a normal human being. They had to hold it above their face and let the Mountain Dew pour into them, like on a commercial. And I go, extreme, XM. Elon Musk hasn't gotten over that shit. We abandoned it a long time ago. Also, if you were a fan of the X-Men in the 90s, you'll notice, how come all these things are X? There's one called Executioner's Song, but they didn't spell it that way. It was just Executioner's Song. I'm like, well, that's not how you spell X. They took the E out. It was just Executioner. I'm like, what the? Now I'm wondering if I'm even remembering that right. I started ignoring Marvel Comics at the time because it was just like the art was very weird. Anybody collect comics? Like from like old comics? Okay, then it doesn't matter. Okay. I think the real question concerning the X-Men is why hasn't Disney just bought Sony? It's like, oh, we want X-Men. And Sony's like, oh, no, you can't have them. It's like, oh, well, we want Sony. And Sony's like, oh, fuck. We'll just buy all of Sony, take the parts that we want. All right. So let's take a break. I know it's a little bit early for that, but let's take a break. Come back at 2 o'clock and we will figure out where are these numbers, A, B, C, and D. Where do those constants show up in the graph? Because they show up in the graph. We'll talk about that. So take a break, come back at 2.